Now we are going to look at some problems based on the addition of vectors, and some of these problems are based on the special cases which I have discussed in the previous session. So before going through these problems, it is better you make yourself familiar with all the results and special cases I have discussed in the previous classes. So I will be showing the problems on the screen one after another, and those who are interested to try these questions themselves, they can take a pause after each problem is shown on the screen. They can try the problem. I have given the answers also, so you can check up your answers. But in case you need explanation for the problems, you can listen to my explanation after the list of the problems. So now look at the problems here one by one on the screen. In each of the following cases, find the angle between the vectors p bar and q bar, and also the angle between the p bar and p bar plus q bar. So you can see the question number 4, magnitude of p bar plus q bar equal to magnitude of p bar plus magnitude of q bar. You can try this question yourself, try to think about the question. You have to find not only the angle between p bar and q bar, you have to also find the angle between p bar and resultant of p bar and q bar. Can see the answers here, 0 degrees and 0 degrees, means angle between p bar and q bar is 0 degrees. Even the angle between p bar and resultant of p bar and q bar is also 0 degrees. See the next question, question number 5. Magnitude of p bar plus q bar equal to magnitude of p bar minus magnitude of q bar. You can take a pause and think about the question. It comes under one of the special cases. Look at the answer here. (180 degrees and 0 degrees). That means angle between p bar and q bar is 180 degrees. The angle between p bar and resultant of p bar and q bar is 0 degrees. So look at the next question. Magnitude of p bar plus q bar is equal to magnitude of q bar minus magnitude of p bar. This is also similar to the previous question with a small difference. You can first think about the answers yourself. Now look at the answers. 180 degrees and 180 degrees. It means angle between p bar and q bar is 180 degrees. The angle between p bar and resultant of p bar and q bar is also 180 degrees. Then look at the next question. Question number 7. Magnitude of p bar equal to magnitude of q bar equal to 1 by root 2 times magnitude of resultant of p bar and q bar. This problem also comes under one of special cases. You can try it. You take a pause and try. Answers are 90 degrees and 45 degrees. That means the angle between P bar and Q bar is 90 degrees. The angle between P bar and resultant of P bar and Q bar is 45 degrees. Next, look at the question number 8, which is similar to the previous question. You can try to answer this question yourself first. If you want little time, you can take a pause. Otherwise, you can look at the solution which I am going to discuss. So look at the solution of the question number 8. It's given that magnitude of P bar same as magnitude of Q bar, which is equal to 1 by root 3 times magnitude of resultant of P bar and Q bar. Or we can write mod of P bar can be written as P. Mod of Q bar can be written as Q. That can be written as 1 by root 3 times magnitude of resultant of P bar and Q bar. So this implies that if you consider first and last, you can write magnitude of resultant of P bar and Q bar equal to root 3 times magnitude of P bar. So we have discussed in one of the special cases, case 4, that if two vectors P bar and Q bar have same magnitude but act in different directions, then magnitude of the resultant of P bar and Q bar is equal to 2p cos theta by 2. With theta is the angle between the two vectors P bar and Q bar. So on the left hand side, you can substitute magnitude of resultant of P bar and Q bar equal to P root 3. Therefore, P root 3 equal to 2p cos theta by 2. Or P root 3 by 2p equal to cos theta by 2. Or you can write cos theta by 2 equal to root 3 by 2. Should be knowing that cos 30 degrees is root 3 by 2. Therefore, theta by 2 equal to, I'm continuing on the right side, theta by 2 equal to 30 degrees. Or theta equal to 60 degrees. That means the angle between P bar and Q bar is 60 degrees. So we make use of the conclusion I have discussed previously. In general, if two vectors of same magnitude have different lines of action, then their vector sum or resultant bisects the angle between the two vectors. Suppose the two vectors P bar and Q bar are represented graphically by the adjacent sides of the parallelogram. such that tail of vector p bar is attached to tail of vector q bar. And the diagonal of the parallelogram passing through their point of intersection represents their vector sum or resultant, both in magnitude and direction. So the direct line segment OA bar represents P bar. The direct line segment OB bar represents Q bar. The angle theta is 60 degrees. That means angle BOA equal to 60 degrees. It's given that the two vectors P bar and Q bar have same magnitude. That means the adjacent sides of the parallelogram have same length. So the parallelogram OACB will be a rhombus. So the resultant bisects the angle between the two vectors. That means alpha equal to theta by 2. When magnitude of vector P bar is same as magnitude of vector Q bar. Here alpha represents the angle made by the resultant of P bar and Q bar with the first vector P bar. That is angle COA equal to alpha. That is theta by 2. That means half of 60 degrees. That is 30 degrees. Therefore, in the given question, the angle between P bar and Q bar is 60 degrees. That is one of the answers. The angle between P bar and resultant of P bar and Q bar is 30 degrees. That is the answer for second part of the question. You can follow similar procedure even for the previous question number 7. That means you can follow the same procedure for all those examples where the two vectors have same magnitude. So we have just discussed the problem number 8. The answers are 60 degrees and 30 degrees. Look at the next problem. Question number 9. Magnitude of P bar equal to magnitude of Q bar equal to magnitude of the resultant of P bar and Q bar. Can follow same procedure even for this question. This problem also comes under one of the special cases. This problem comes under special cases 4 and 5. You can take a pause and try this problem yourself. You can look at the answers here. 120 degrees and 60 degrees. That means the angle between P bar and Q bar is 120 degrees. The angle between the resultant and P bar is 60 degrees. In one of the special cases, I have discussed one important conclusion. That is the last special case in parallelogram law of addition of vectors. If two vectors have same magnitude and if they are inclined to each other an angle of 120 degrees, then the magnitude of their vector sum or resultant will be same as the magnitude of any one of the vectors. Next, look at the question number 10. Magnitude of P bar is equal to half of magnitude of Q bar, which is equal to 1 by root 3 times magnitude of the resultant of P bar and Q bar. You can take a pause here and try the problem yourself first. Otherwise, look at the solution which I am going to discuss. Look at the solution of the question number 10. It's given that magnitude of P bar equal to half of magnitude of Q bar, which is also equal to 1 by root 3 times magnitude of resultant of P bar and Q bar. As I told you, sum of two vectors means resultant of two vectors. So whenever I write p bar plus q bar, you make it a habit to read it as resultant of p bar and q bar. So in such problems, we try to express all the three magnitudes in terms of one of the magnitudes. So first and second, you can observe that magnitude of p bar equal to magnitude of q bar by 2. So this you can write this way: p equal to q by 2 or q equal to 2p. Next, if you combine first and last, you can observe that magnitude of p bar is 1 by root 3 times magnitude of resultant of p bar and q bar. Or you can write magnitude of resultant of p bar and q bar root 3 times the magnitude of vector p bar, called second equation. If theta is the angle between the two vectors p bar and q bar, then we can write square of the magnitude of resultant of p bar and q bar is equal to p square plus q square plus 2pq cos theta. From the result which I discussed previously in the parallelogram law of addition of vectors. So in this equation, on the right hand side, you can substitute q equal to 2p from this equation number 1. On the left hand side, you can write modulus of p bar plus q bar equal to p root 3. So therefore, on the left hand side, you can write modulus of p bar plus q bar equal to p root 3. On the right hand side, you can substitute q equal to 2p. So you get 3p square equal to p square plus 4p square plus 4p square cos theta. So p square plus 4p square will be 5p square. You can carry it to the left hand side. So from this you get minus 2p square by 4p square equal to cos theta. Or you can write cos theta equal to minus 1 by 2. That means cos theta equal to minus 1 by 2. You know that cos 60 degrees is 1 by 2. But you have minus 1 by 2 here. That means theta equal to 180 degrees minus 60 degrees. Or theta equal to 120 degrees. It means the angle between the vectors p bar and q bar is 120 degrees. Next, we are also asked to find the angle alpha made by the resultant vector with the first vector p bar. So, using the equation for direct of the resultant, we can write tan alpha equal to q sin theta by p plus q cos theta. So from the equation 1, you can substitute q equal to p on the right hand side. And here we got theta as 120 degrees. That can be substituted on the right hand side both in numerator and denominator. So we get q equal to 2p here. Theta is 120 degrees. P plus 2p into 120 degrees. So we get 2p into sine 120 degrees is same as sine 60 degrees. That is root 3 by 2. Cos 120 degrees equal to minus 1 by 2. So you get p root 3 by 0, which can be written as so tan alpha equal to infinity. Therefore, alpha is 90 degrees. So here alpha is the angle made by the resultant of the two vectors p bar and q bar with the first vector p bar. So the answers are 120 degrees and 90 degrees. That means the angle between p bar and q bar is 120 degrees. The angle between resultant and first vector p bar is 90 degrees. We can also represent the vectors graphically by the adjacent sides of the parallelogram. You can draw a parallelogram by representing the vectors p bar and q bar graphically by the adjacent sides such that tail of q bar is attached to tail of p bar like this. Of course, you have to take length of this line to be double the length of this line actually when you draw on the paper. And we got alpha equal to 90 degrees. Means resultant is perpendicular to the first vector p bar. In the diagram, the direct line segment OA bar represents p bar. The direct line segment OB bar represents vector q bar. OACB is the parallelogram. OC bar represents the resultant R bar. That means here R bar represents resultant of P bar and Q bar. Here we got theta as 120 degrees. So theta is the angle between P bar and Q bar. That means angle BOA is 120 degrees. Angle BOA is 120 degrees. And alpha is 90 degrees. That means angle COA is 90 degrees. Of course, sometimes you may be asked to find this angle denoted by beta between Q bar and resultant. So that will be equal to how much? Alpha plus beta will be equal to theta here. Alpha is the angle made by the resultant with the first vector. Theta is the angle between P bar and Q bar. So here theta is 120 degrees, so alpha is 90 degrees. So beta will be 120 degrees minus 90 degrees, that will be 30 degrees. So we have just discussed the question number 10. The answers are 120 degrees and 90 degrees. Next, look at the question number 11. Magnitude of P bar by root 3 equal to magnitude of Q bar is equal to magnitude of the resultant of P bar and Q bar. This you can take a pause and try this problem yourself. Now see the answers. 150 degrees and 30 degrees. That means the angle between P bar and Q bar is 150 degrees. And the angle made by the resultant of the two vectors P bar and Q bar with the first vector P bar is 30 degrees. Next, I would like to show you the next few questions also. After you have finished trying all the problems, then we may look at the solutions of the next questions. So first you look at the problems here. Later, I will discuss some of these problems. In case you are unable to arrive at the answers or not convinced with the answers, you can look at the solutions I discuss after the list of the problems. Next, you see the question number 12. Magnitude of P bar equal to magnitude of Q bar by root 3 equal to magnitude of resultant of P bar and Q bar. This problem is also similar to the previous one, but a small difference will be there. So if you practice the problems, you will be able to observe the difference. First, you can take a pause and try this problem also yourself. The answers are 150 degrees and 120 degrees. It means the angle between P bar and Q bar, you are supposed to get it as 150 degrees. The angle between P bar and resultant of P bar and Q bar has 120 degrees. Then see the next question. Question number 13. Magnitude of P bar equal to magnitude of Q bar by root 2. That is equal to magnitude of the resultant of P bar and Q bar. This problem also can try it yourself. The answers are 135 degrees and 90 degrees. That means the angle between P bar and Q bar is 135 degrees. Angle made by the resultant vector with the first vector P bar is 90 degrees. Next, you see the question number 14. It's given that magnitude of P bar by 3 equal to magnitude of Q bar by 4. That is equal to 1/5 of the magnitude of the resultant of P bar and Q bar. This can also be done by similar procedure, or you can also use the triangle law of vector addition. You can take a pause and try this problem yourself first. Look at the answers here. 90 degrees and 53 degrees. It means angle between P bar and Q bar is 90 degrees. The angle between P bar and resultant of P bar and Q bar is 53 degrees. Next question is also similar to that previous question. I given for your practice. Magnitude of P bar by 5 equal to magnitude of Q bar by 4 is equal to magnitude of P bar plus Q bar by 3. Of course, in these questions, you have to use the result that is given in the last. That is find 53 degrees equal to 4 by 5 and find 37 degrees equal to 3 by 5. Wherever it is necessary, you have to take the value of sin 53 degrees to be same as cos 37 degrees equal to 4 by 5. And sin 37 degrees is same as cos 53 degrees equal to 3 by 5. Now similarly 15th and 16th questions are also similar. You can try them yourself. Even the 17th one is also similar to that. For this question, you take sin 23 degrees equal to 5 by 13. For this question, you have to take sin 23 degrees equal to 5 by 13. So I have given those numeric trigonometric ratios required to answer the last few questions here on the screen. Sine 23 degrees equal to 5 by 13. And wherever necessary, you have to use these trigonometric relations. Sine 180 degrees minus theta equal to sine theta to find some of the trigonometric ratios. Cos 180 degrees minus theta equal to minus cos theta. Of course, these conclusions are discussed for MPC students in the trigonometry, but even biology students should also expect to remember these conclusions to solve some problems in the 11th class or intermediate first year syllabus. For example, I am giving an example for this formula. Suppose if you take theta as 45 degrees, if you want to find the value of sine 135 degrees, 135 degrees can be written as sine 180 degrees minus 45 degrees using this formula. Here I have sine 180 degrees minus theta equal to sine theta. The same way sine 180 degrees minus 45 degrees can be written as sine 45 degrees. You are supposed to know the value of sine 45 degrees, which is equal to 1 by root 2. Similarly, you can find the value of sine 150 degrees. 150 degrees can be written as 180 degrees minus 30 degrees. Using this formula, sine 180 degrees minus theta equal to sine theta. Here in place of theta, I have 30 degrees. So sine 180 degrees minus 30 degrees can be written as sine 30 degrees. The value of sine 30 is 1 by 2. It means sine 150 degrees is also equal to 1 by 2. Now see, if you have tried all the problems, it's okay. But some of the students may need explanation. Therefore, I would like to discuss some of the problems. Here, look at the question number, problem number 11. Here on the screen, mod of p bar by root 3 equal to mod of q bar, that is equal to magnitude of the resultant of p bar and q bar. Here also can try to express all the three magnitudes in the formula for the magnitude of the resultant in terms of one of the magnitudes. So in the general equation r square equal to p square plus q square plus 2pq cos theta, we can express all the three magnitudes in terms of one of the magnitudes. So we can try to express all the three magnitudes in terms of p or in terms of q also, either way. So combining the first two, we can observe that magnitude of q bar, magnitude of p bar, you can write root 3 times magnitude of q bar, or p equal to q root 3. You can considering this we call one equation. You consider the last two. Magnitude of the resultant of p bar and q bar same as magnitude of q bar. That means you can write as q. Call that as equation 2. So if theta is the angle between the vectors p bar and q bar, then we have the expression for magnitude of the resultant of p bar and q bar, or you can write square of the magnitude of the resultant of p bar and q bar, because to find the value of cos theta, you have to square the equations both sides, equal to p square plus q square plus 2pq cos theta. You can substitute here p equal to q root 3 on the right hand side, and you can substitute magnitude of the resultant of p bar and q bar equal to q on the left hand side from equation 2. So from equation 1, you can write p equal to q root 3 here. And from equation 2, we can substitute magnitude of the resultant of P bar and Q bar equal to Q. Therefore, you get Q square equal to, you can write P equal to Q root 3 on the right side. P square can be written Q root 3 whole square plus Q square plus 2 into Q root 3 into Q cos theta. So this you get 3Q square plus Q square plus 2 root 3 Q square cos theta. So you get 4Q square plus 2 root 3 Q square cos theta on the right hand side. On the left hand side, you have Q square. So Q square minus 4Q square equal to 2 root 3 Q square cos theta. Or you can write minus 3Q square by 2 root 3 Q square equal to cos theta. So you get cos theta equal to minus 3 by 2 root 3. Cos theta you get minus 3 by 2 root 3. The 3 you can write root 3 into root 3. So you get cos theta equal to minus root 3 by 2. You must be knowing the value of cos 30 degrees. Cos 30 degrees is root 3 by 2. So we got minus root 3 by 2. That means cos theta is same as minus cos 30 degrees. As you know that cos 180 degrees minus theta equal to minus cos theta. Therefore, theta you get 180 degrees minus 30 degrees. That is equal to 150 degrees. So that is one of the answers. It means angle between the vectors P bar and Q bar is 150 degrees. Then to find the angle made by the resultant of the two vectors with the first vector P bar, we can use the formula for the direction of the resultant. We got the angle theta between P bar and Q bar as 150 degrees. So to find the angle made by the resultant of the two vectors P bar and Q bar with the first vector P bar, we use the expression for the direction of the resultant. As you know that if alpha is the angle made by the resultant of P bar and Q bar with the first vector P bar, then tan alpha equal to Q sin theta by P plus Q cos theta. So here we can substitute theta equal to 150 degrees on the right hand side. And as we discussed in the beginning of the problem, P equal to Q root 3. We can substitute P equal to Q root 3 on the right hand side from equation number 1. So Q sin 150 degrees by, we got from equation 1 P equal to Q root 3 plus Q cos 150 degrees. As I explained how to calculate the value of sin 150 degrees, same as sin 30 degrees, that is 1 by 2. The value of cos 150 degrees is minus cos 30 degrees or minus root 3 by 2. So here you get Q into 1 by 2 divided by q into root 3 to 1 minus 1 by 2. So if you simplify this, you get tan alpha equal to 1 by root 3, or alpha equal to 30 degrees. So this is one of the answers. This is another answer. This is one answer. That means angle between P bar and Q bar is 150 degrees. The angle made by the resultant of the two vectors P bar and Q bar, with the first vector P bar we got 30 degrees. Sometimes you may be even asked to find the angle made by the resultant with the second vector Q bar. Here the two vectors P bar and Q bar can be graphically represented by the adjacent sides of the parallelogram. The direct line segment OA bar represents the vector P bar. So given that the angle between P bar and Q bar is 150, we got the answer. It's not given, but we have solved it. We got the answer for the first part of the question as 150 degrees. That means the angle between P bar and Q bar is 150 degrees. So the angle BOA is 150 degrees here. So the direct line segment OA bar represents the vector P bar, and OB bar represents the vector Q bar. So the diagonal of the parallelogram passing through the point of intersection represent the resultant. So in the figure OACB, the parallelogram, OC bar represents resultant of P bar and Q bar. So this angle alpha represents the angle made by the resultant with the first vector P bar. Let beta denote the angle made by the resultant with second vector Q bar. Of course, it's not necessary to draw the diagram to solve the problem I have given, because in the given problem you are asked only to find theta and alpha, which you have completed. But in case you may be asked to find angle between second vector Q bar and resultant, that is angle BOA can be written as angle BOC plus angle COA. That means theta can be written as beta plus alpha, or beta can be written as theta minus alpha. We got theta as 150 degrees, alpha as 30 degrees. So you get beta as 120 degrees. Here beta is the angle made by the resultant with the second vector Q bar. Next I am going to discuss the question number 17. You are given that magnitude of P bar by 5 equal to magnitude of Q bar by 12 equal to magnitude of resultant of P bar and Q bar by 13. I'd like to discuss this particular question. Look at the screen here for the solution. So it's given in the problem that magnitude of P bar by 5 equal to magnitude of Q bar by 12, that is equal to magnitude of the resultant of P bar and Q bar by 13. Let us denote each of these magnitude for our convenience. Let us denote it by letter N, or some other letter which is a constant. So from first and last, you can write magnitude of P bar by 5 equal to N, or magnitude of P bar equal to 5N, or P equal to 5N. Similarly, by using the second and last, you can write magnitude of Q bar by 12 equal to N, or you can write Q equal to 12N. Considering the last two, magnitude of the resultant of P bar and Q bar equal to 13n. This problem can be solved by two methods. This problem can be solved by the same method which I have discussed for the question number 11 previously, or otherwise you can also follow an alternate method based on the triangle law of vector addition. In some of the problems, triangle law of vector addition may be more convenient or easier, particularly when the three vectors form a right angle triangle. How to know whether the three vectors form a right angle triangle? If the magnitudes of the three vectors suppose satisfy the condition of Pythagoras theorem, then the three vectors, I mean p bar, q bar and resultant of p bar and q bar, can be represented along the three sides of the right angle triangle. You can observe that in this problem, if you square the magnitudes of p bar and q bar and add them, that is p square plus q square equal to 5n whole square plus 12n whole. That means we are adding the squares of the smaller magnitudes. That comes out to be 25n square plus 144n square, which will be equal to 169n square, or that can be 13n whole square. You can observe that sum of the squares of the magnitudes of the two vectors p bar and q bar is equal to square of the magnitude of the resultant. That means the two vectors p bar and q bar can be represented by the smaller sides of the right angle triangle. The largest magnitude has to be represented by the hypotenuse side. According to the triangle law of addition of vectors, if two vectors can be graphically represented by the two sides of the triangle, all taken in the same order, and third side of the triangle taken in the reverse order, represent the resultant of the two vectors. So here p bar is perpendicular to q bar. Therefore, the two vectors p bar and q bar can be graphically represented by the adjacent sides, by the two sides of a right angle triangle. Your vector p bar is perpendicular to vector q bar. Head of vector p bar is attached to tail of vector q bar. That means, as I discussed previously, two vectors are said to be in the same order if they are represented graphically, such that head of one vector attached to tail of other vector. And the third side of the triangle taken in the reversed order represents the resultant of p bar and q bar, which may be denoted by r bar. So here p bar is perpendicular to q bar. So angle between p bar and q bar is 90 degrees. Let alpha be the angle made by the resultant of the two vectors with the first vector p bar. So from the figure, you can observe cos alpha equal to magnitude of p bar by magnitude of the resultant of p bar and q bar. So from first equation, magnitude of p bar is 1. Of course, you can even calculate sin alpha also to find alpha. Magnitude of the resultant of p bar and q bar 13n. So we got 5n by 13n. That means cos alpha is equal to 5 by 13. That's already given in the problem that 5 by 13 gives you the value of sine 23 degrees. That means here the value of cos alpha is same as sin 23 degrees. So using the relation in trigonometry, sin 90 minus theta equal to cos theta, or cos 90 minus theta equal to sin theta. You can use that relation here. So you can write cos alpha equal to sin cos of 90 minus 23 degrees, or alpha equal to 90 minus 23 degrees. That will be equal to 67 degrees. So alpha is the angle made by the resultant of the two vectors p bar and q bar with the first vector p bar. So the answers for the problem are theta equal to 90 degrees, means angle between p bar and q bar is 90 degrees. Alpha equal to 67 degrees. That means the angle made by the resultant of p bar and q bar with the first vector p bar is 67 degrees. Now see, I would like to discuss same problem by an alternate method. So it's given that is by using the parallelogram law of vector addition. This alternate method is based on the results of the parallelogram law of addition of vectors. So it's given that magnitude of p bar by 5 equal to magnitude of q bar by 12 is equal to magnitude of resultant of p bar and q bar by 13. That is n. So as we have discussed in the even in the previous method, here you can write p equal to 5n, q equal to 12n, and magnitude of the resultant of p bar and q bar equal to 13n. So if theta is the angle between the vectors p bar and q bar, then we know that square of the magnitude of resultant of p bar and q bar equal to p square plus q square plus 2pq cos theta. So on the left hand side you can write magnitude of the resultant of p bar and q bar equal to 13n. The right hand side you can substitute p equal to 5n. Next you can substitute q equal to 12n. So from first equation you can substitute p equal to 5n and q equal to 12n. You can simplify this. You can try to simplify this yourself. If you simplify this, you get cos theta equal to 0, means theta is 90 degrees. It means angle between the vectors p bar and q bar is 90 degrees. That means the vectors p bar and q bar are perpendicular. So using the expression for direction of the resultant, you can write tan alpha equal to q sin theta by p plus q cos theta. You can substitute again here q equal to 12n and p equal to 5n and theta equal to 90 degrees. Q equal to 12n, theta equal to 90 degrees. So sin 90 degrees equal to 1. Cos 90 degrees is 0. So you get tan alpha equal to 12 by pi. So what is given in the problem? You are not given the value of tan inverse 12 by 5. Of y is tan inverse 12 by 5. But you are not given the value of tan inverse 12 by 5. What is given in the problem? You are given that sine 23 degrees equal to 5 by 13. So you can draw a right angle triangle separately. Take one of the angles as alpha. Sine 23 degrees is given to 5 by 13. That means you can, this angle is 23 degrees. Otherwise, you can look at the diagram here on the right side. This angle we take it as 23 degrees. This is 90 degrees. As you must be knowing that some of the angles at the three vertices of the triangle is 180 degrees. One of the angles is 90 degrees. So sum of these two angles is 90 degrees. So this angle is 23. So this will be 67 degrees. Because it is given that sine 23 is 5 by 13. That means you can take sine 23 length of side opposite to 23 degrees divided by length of the hypotenuse side. So you take this length as 5 units, this length as 13. You can apply Pythagoras theorem to find the length of this side. That comes out to be 12 units. You can observe from the figure 12 by 5 from this figure. That means length of this side. What we got is tan alpha equal to 12 by 5. From this figure you can observe that length of this side divided by length of this side gives you tan of this angle. That means tan 67 degrees equal to 12 by 5. That means you can take alpha as 67 degrees. Means the angle made with the resultant with the first vector p bar is 67 degrees. So I have solved the question number 17. Before this, you can follow similar procedure for the three questions 14, 15, 16. You can follow same method or similar procedure for questions 14, 15 and 16. These three questions also can be done by any one of the two methods I discussed, that is either by applying the triangle law of vector addition or alternately by using the results discussed based on the parallelogram law of vector addition. Because in these questions 14, 15 and 16, you can observe that the vectors p bar, q bar and the resultant of the two vectors p bar and q bar, they can be represented along the sides of a triangle, right angle triangle. Remember that when they are represented along the sides of a right angle triangle, the one which has largest magnitude has to be represented along the hypotenuse side. And the two vectors p bar and q bar must be represented in the same order, that is head of p bar attached to tail of q bar.